Hello everyone, my name is Mingkun from the University of Illinois at Urbana-Champaign. Here I want to introduce our project about predicting chatbot popularity before deployment. This work was done during my internship at IBM with Xiaotong, Anbang, and Rama Akkiraju. Nowadays, chatbots are widely used in different scenarios by countless big tech companies and startups. In terms of how to evaluate chatbot, people mainly rely on human evaluation with relatively subjective metrics. One problem here is previous research provides little support for early-stage comprehensive diagnosis of chatbot design before deployment in a fully automatic way. Why early-stage diagnosis of chatbot design is important? Because the economic cost of chatbot failure is huge. Usually it costs $25,000 to $30,000 to design, build, and deploy an enterprise-level chatbot. In addition, for a fully functional and powerful chatbot, it can cost $150,000. And what makes early-stage diagnosis more important is that research showed that most people won't come back to use the chatbot if the chatbot leaves a negative first impression to users. Currently, a comprehensive human evaluation for enterprise-level chatbots can only be conducted after a full, expensive development life cycle. If there's design flaw found later, the economic cost is inevitable. In this work, our contribution includes: first, we propose a computational approach to making a priori prediction about chatbot's popularity, which indicates chatbot general performance before deployment. Then we identify key design features for chatbot design. In terms of chatbot design, let's first look at a simple example of flower ordering chatbot. Usually, a chatbot design contains three main parts: intent design, conversation flow design, and response design. Intent design identifies what user intent the chatbot can satisfy. In the example of flower ordering chatbot, there are four intents: greeting, ordering flower, reordering, and goodbye. For each intent, the chatbot designer needs to design the utterances which can evoke the intent. The orange text box on the top shows the utterance example of the greeting intent. And the conversation flow design shows how the conversation flows in the dialogue. You can see the conversation flow in the green part in the middle in the image. Finally, the response design shows how the chatbot will reply to users' input. In our example, you can see the response of the goodbye intent in the black text box at the bottom. In our approach, we extract features about these three aspects to train the model for prediction. Let's first look at intent features. A chatbot can have multiple intents, and for each intent, people need to design utterances which invoke the corresponding intent. In our study, we extract utterance readability features, utterance representation features, utterance linguistic features, and intent description features. Next, given that chatbot conversation flow is a graph, we extract some graph-based features to describe the conversation flow. Finally, for response features, we extract response readability, response linguistic, and response representation features. You can check our paper for the details of all these features mentioned above. In our work, we studied 1,050 customer service chatbots about banking, retail, insurance, and telecommunication, which were deployed by large enterprises and were active during January 1st, 2018 to January 31st, 2018. We used the number of successfully completed conversations during this period on each chatbot to indicate chatbot popularity. Here we show the distribution of chatbot in terms of the number of successfully completed conversations. The table shows some descriptive statistics of the minimum first decile, median, the ninth decile, and a maximum number of conversations among all chatbots. In terms of analyzing method, first we conduct two classification tasks to see whether it's possible to predict chatbot popularity before deployment. The first one is a two-class classification task with a median split. The second task is a three-class classification task to train model to predict among very popular, very unpopular, and in-between chatbots. Next, our task is to identify key design features. First, we train model to predict between very popular and very unpopular chatbots. Then we select 100 most important features by the model trained on all features. Finally, to find key design features, we conduct a Mann-Whitney U-test with Bonferroni adjustment with respect to each of these 100 features to see which features are significantly different between these very popular and very unpopular chatbots. Here, I would like to highlight some results. We use balanced accuracy to measure the prediction accuracy. First, for the median split classification task, our prediction accuracy is about 63%, and for the three-class classification task, our accuracy is about 51%. For the classification task between very popular and very unpopular chatbots, the prediction accuracy is about 77%. These classification results indicate that it's possible to predict chatbot popularity before deployment and give early-stage diagnosis. Next, let's look at key design features, which show significant difference between very popular chatbots and very unpopular chatbots. First, let's look at key intent features. From the result, we can see that for utterance readability, popular chatbots have a higher readability score than unpopular chatbots for all these readability metrics. The higher the readability score is, the harder the text can be understood. Thus, popular chatbots' utterances are harder to understand than unpopular chatbots. In addition, popular chatbots have more utterances designed. This may be caused by the fact that popular chatbots have a larger scale with more intent. Finally, we find that for all key utterance linguistic features that show significant differences between very popular and very unpopular chatbots, they have a higher frequency of occurrence in popular chatbots than unpopular ones. This indicates that popular chatbots' utterances cover a richer set of common and representative vocabularies. In terms of key conversation flow features, we find that popular chatbots have more vertices, which means they can fulfill more user intents. This also explains why popular chatbots have more utterances. Even though popular chatbots have more vertices in the conversation flow graph, the graph density is lower than that of unpopular chatbots. This indicates that the conversation flow of popular chatbots is designed in a more concise way. Finally, let's look at key response features. First, we can see that popular chatbots have more responses with link and responses with emoji compared to unpopular chatbots. This may be caused by the fact that popular chatbots are designed in a larger scale of intent. However, the significantly higher percentage of responses with link of popular chatbots clearly shows that popular chatbots have more responses having link with them, which can help users access external information more easily. In addition, for all key response linguistic features that show significant difference between very popular and very unpopular chatbots, they have a higher frequency of occurrence in popular chatbots than unpopular ones. This indicates that popular chatbots' responses cover a richer set of common and representative vocabularies. Here, let's summarize design implications from our study. First, popular chatbots are designed in a larger scale of intents with more functionalities. Second, for utterances and responses, we should use more representative and common vocabularies. Third, the conversation flow should be designed in a concise way. Fourth, designers should not expect user input to be very easy to understand. Finally, responses should include links to external information if necessary. Now, I want to illustrate these design implications with our example. First, there are 4 intents in the flower ordering chatbot. The scale of the flower ordering chatbot may be too small to fulfill users' demands. The designer should expand the functionalities of the chatbot and add more intents, such as pickup intent, delivering intent. Then there are 2 utterances, hello and hey, designed to invoke the intent greeting. These 2 utterances are very easy to understand. For the intent greeting, we can add some hard-to-understand utterances with casual phrases. Next, our design implication suggests that we should include some links in responses if necessary. For example, for the responses in the ordering flower intent, we can add some links to external websites introducing different types of flowers. Finally, even though we may need to add more intents, we need to keep the conversation flow as concise as possible. Thank you very much.